Assalamualaikum warahmatullahi wabarakatuh. Hi, my name is MUHAMAD JASMANI. I'm from section 3, group 2. I will present about crank motion, which is our group consists of Muhammad Hazim bin Jumali, Muhammad REZQAL bin RAMLAN, and Muhammad Adam SUFI bin Muhammad SAFRI. Now I will present about the objective of the crank motion. Firstly, to understand the concept of the crank motion, to measure the rate at which turning moment varies and rate during each the turning moment is zero. Last but not least is to observe the difference between experimental and theoretical torque value. That's all for me. Now I will pass to the next presenter. Thank you.
Now move to the observation part. In this crank motion laboratory experiment, we got to observe the maximum of turning moment when the crank motion's angular displacement reached 90 degrees. We get to observe that the greater force being applied, the higher the momentum. In this experiment, when the maximum force occurred at the angle of 90 degrees, the forces was 3.6 Newton. Meanwhile, when the angle is at 0 degree, the force is at minimum value, which is 0 Newton. After it reached the angle of 90 degree, the turning moment value is decreasing until 180 degree. The force value in our experiment is constantly increasing until at 180 degree we get 7.7 Newton. The theoretical values of our experiment values have some different. This is because of the factors that affected our experiment. For the theoretical value at 90 degree, it stated 74 Newton millimeter. There is 2 Newton millimeter difference between theoretical and experiment that caused by an error when conduct the experiment. That's all for the observation part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Sufi. So now I will present about apparatus and procedure. Number 1 is load set of 500 gram. The load used as an ideal object measures for small time experiment. Number 2 is slider load. Slider load is a device that used to accommodate a number of weights. Number 3 is spring balance. Spring balance commonly used to measure the force exerted on an object during experiment. Number 4, follower shaft. It is used as a guide roller for cam mechanism or straight motion. Number 5, crank arm with fixing. Used to adjust the slide load on the bearing and holds the arm in place while you tighten up the crank hinge bolt to the proper torque spec. And the last one is shaft guide. It is also used as guide roller for cam mechanism or straight motion. All of the apparatus must be set up as shown on the figure 3. So for the procedure, we need to place a mass of 500 gram on the slider load. The weight on the hook will pull the crank out flat, by the position generally called dead center, which is the angle equal to 0. Then set the indicator start at scale 30 mm. After that, hang the spring balance with adjustable hook. Ensure the value of spring balance is 0. Then shift the adjustable hook until the angle equal to 10. Then fix the piston and record the spring balance reading. Repeat the previous step and each time increasing the angle by 10. The final angle is 180 from 0. And last one is fill the result on the table. Thank you.
Move to the results of our experiment. After making the crank motion experiment in the laboratory, we have recorded the data required, which is the force and also the measured torque. In that experiment, at 0 degree, we get the force is equal to 0 Newton and the measured torque is equal to 0 Newton millimeter. At 10 degree, the force is 0.2 Newton and the measured torque is equal to 4 Newton millimeter. At 20 degree, we get the force is equal to 0.5 Newton and the measured torque is equal to 10 Newton millimeter. At 30 degree, the force is equal to 1.0 Newton and the measured torque is equal to 20 Newton millimeter. At 40 degree, the force is equal to 1.4 Newton and the measured torque is equal to 28 Newton millimeter. At 50 degree, the force is 1.9 Newton, and the measured torque is equal to 38 Newton millimeter. Next, at 60 degree, the force is equal to 2.4 Newton, and the measured torque is equal to 48 Newton millimeter. At 70 degree, the force is equal to 2.8 Newton, and the measured torque is equal to 56 Newton millimeter. At 80 degree, the force is equal to 3.3 Newton, and the measured torque is equal to 66 Newton millimeter. At 90 degree, the force is equal to 3.6 Newton, and the measured torque is equal to 72 Newton millimeter. At 100 degree, the force that we get is equal to 4.1 Newton, and the measured torque is equal to 82 Newton millimeter. At 110 degree, the force we get is 4.5 Newton, and the measured torque is equal to 90 Newton millimeter degree. At 120 degree, the force is equal to 5.0 Newton, and the measured torque is equal to 100 Newton millimeter. At 130, the force that we get is equal to 5.5 Newton, and the measured torque is equal to 110 Newton millimeter. At 140 degree, the force is equal to 5.9, and the measured torque is equal to 118 Newton millimeter. At 150 degree, the force is equal to 6.3 Newton, and the measured torque is equal to 126 Newton millimeter. At 160 degree, the force is equal to 6.8 Newton, and the measured torque is equal to 136 Newton millimeter. And at 170 degree, the force is equal to 7.3 Newton, and the measured torque is equal to 146 Newton millimeter. And the last is 180 degree. The force is equal to 7.7 Newton, and the measured torque is 154 degree Newton millimeter. We move to the next part, which is the perform measurement. In this part, we need to calculate the turning moment by using the formula of turning moment, which is R times E equal to F times D, where R is equal to the flywheel radius, and E is equal to the turning force, F is equal to the force at the chord, and D is equal to the distance between the line of force and the center of rotation. So, the information that we get from the lab sheet is the radius of flywheel is equal to 20 mm. So, after do the calculation, we at 0 degree, we get the turning moment is equal to 0 Newton millimeter. At 10 degree, we got the turning moment is equal to 4 Newton millimeter. At 20 degree, we got the turning moment is equal to 10 Newton millimeter. At 30 degree, we got the turning moment is equal to 20 Newton millimeter. At 40 degree, we got the turning moment is equal to 28 Newton millimeter. At 50 degree, we got the turning moment is equal to 38 Newton millimeter. At 60 degree, we got the turning moment is equal to 48 Newton millimeter. At 70 degree, we got the turning moment is equal to 56 Newton millimeter. 80 degree is equal to 66 Newton millimeter. At 90 degree, we got the turning moment is equal to 72 Newton millimeter. Next, at 100 degree, we got the turning moment is equal to 62 Newton millimeter. At 110 degree, we got the turning moment is equal to 54 Newton millimeter. And at 120 degree, we got the turning moment is equal to 44 Newton millimeter. At 130 degree, we got the turning moment is equal to 34 Newton millimeter. 140 degree is equal to 26 Newton millimeter, and 150 degree we got the turning moment is equal to 18 Newton millimeter. At 160 degree we got the turning moment is equal to 8 Newton millimeter, and at 170 degree we got the turning moment is equal to negative 2 Newton millimeter, and the last is 180 degree we got the turning moment is equal to negative 10 Newton millimeter. That's all for the perform measurement part.
Hi, my name is Hazim. I will present for part conclusion for the lab report. For this lab report. In conclusion, the objective was successfully achieved, which is to understand the crank mechanism, which consists of a collection of a mechanical component was constructed to transform a motion into a rotating motion. We may determine from this experiment that the application in real life are piston engine straight line and the piston pumps. Throughout this experiment, we as a group we are able to effectively perform the experiment and achieve our experiment objective. The observed and theoretical torque obtained from the experiment at an angle of 0 degree we were 0 Newton millimeter. Not only that, we also successfully to calculate all the turning moment values during each revolution. Last but not least, we also doing this experiment carefully due to prevent misdata or error when doing it. That's all for me. Thank you.